Hello, welcome to 9-2B Parallel Circuit Math Guided Practice. So if you look at the bottom of your notes page, you have the guided practice. Guided practice, the first part of it reads, an 18 ohm, 9 ohm, and 6 ohm resistor are connected in parallel to an EMF source. A current of 4 amps is in the 9 ohm resistor. Calculate the equivalent resistance on each resistor. So 1 over R1 is going to be 1 over 18 plus 1 over 9 plus 1 over 6. And if you actually plug this into your calculator just like that with the parentheses and everything, you come up with RT equals 1 over 0.33. So if you actually plug that into your calculator and divide 1 by 0.33, your R equivalence, or your R total, comes up to 3 ohms. Your answer is 3 ohms. The second part of the guided practice says calculate the potential difference in the current in the other resistors. So we're calculating both the potential difference, or the voltage, and the current in the other resistors. So we ready to get this started? All right, let's do this. Well, don't forget the answer for the first one was 3 ohms, because we're going to need to know that. So the very first step you should take to solve this, the very first step is that you know that you have R2 equals 9 ohms. You know that I2 equals 4 amps. So all you need to do is solve for your V. Well, according to our triangle, in order to solve for V, we have to multiply. So V is going to equal 9 times 4. So our V, which happens to be the total, is 36, which also happens to be V1 and V2 and V3 and V4 and V whatever's, however many V's there are. Our V total is 36 volts. That's going to come in handy. Now we can solve the rest of them. If we solve the rest of them, this will be the second step. If we know that RT equals 3, and we know that R1 is equal to 18, and we know that R2 is equal to 9, and we know that R3 is equal to 6. We know this because it tells us that right here. So let's make a little graph. Let's look at our I's. We don't know our IT yet, so let's just leave that blank. I1, we're not sure about that yet. I2, well, we're told that I2 is 4. I3, we're not sure about that yet either. Let's look at our V's. VT is going to equal 36, which also means that V1 is going to equal 36, and V2 is going to equal 36 volts, and V3 is going to equal 36 volts, because in a parallel circuit, everything, or all your V's, are equal to each other. So now let's go in and figure out what all we need to do next. So the next thing that's probably going to be the easiest to figure out is going to be your I's. So if we start with R1, we know that R is equal to 18. We know that our V is equal to 36. So if you use your triangle to find out I, it's V divided by R. So 36 divided by 18 is going to equal 2. So I1 is 2 amps. We can use that on the next one down here. R3 is 6. V is 36. So this is going to be 36 divided by 6 which is going to equal 6 amps. Well, now we have 6 amps, 4 amps, 2 amps. If you look at your formula, you know the ITs are all added together. So your total for your I's is going to be 2 plus 4 plus 6, which comes up to 12. Or the other way you could do that is to plug this and this into your formula, so you end up with 36 divided by 3, which also equals 12. All right, so hopefully you understood how to do this math. It's a lot easier if you set it up in grids like we did. That way you can figure out what you need to fill in. If at this time you have any questions, please go see your teacher so they can help you out. Thanks. Have a great day.